Hello, and welcome to Skynet Today's Last Week in AI podcast. We can hear us chat about what's going on with AI. As usual, in this episode, we will summarize and discuss some of last week's most interesting AI news. You can also check out our Last Week in AI newsletter at lastweekin.ai for articles we did not cover in this episode. I am one of your hosts, Andrei Kurenkov. I finished my PhD where I studied AI earlier this year, and now I'm working at a generative AI startup.
And I'm host number 2. My name's Jeremy Harris. I'm the co-founder of an AI safety company called Gladstone.ai. We do a bunch of technical work on alignment and then a bunch of work on AI safety governance stuff. So that's where I'm coming from. And Andre, we were talking before we started recording. Apparently, there have been some interesting bits of user feedback or listener feedback, I should say.
Yeah, so last week we've been mentioning this whole existential risk stuff. I think we had a mini discussion last week. So we got some good feedback from a couple of listeners that they would actually be interested in us chatting about it. There was an interesting 3-star review on Apple Podcasts.
Nice.
That says heavy existential risk bias. It's heavily, so this review says that the podcast is heavily tilted toward existential risk as if it were a event fact, which kind of is surprising because I would say we are kind of diametrically opposed on it.
That's interesting. Yeah.
I'm not a big X risk fan. I do agree that AI risk is a real thing. There's many different reasons why we do need to be concerned with potential outcomes, but I do tend to be skeptical of X risk as kind of a primary thing to worry about. So maybe that wasn't clear so far, and just based on the feedback, we probably will try and schedule in some sort of a podcast episode entirely for it. Yeah.
Yeah, I think that's an interesting piece of feedback too. I mean, it is certainly the case that I think that AI existential risk is very real. And I think that it's really important to have that argument too. One of the things I do try to do for what it's worth is highlight articles that, go the other way. Even if I do give my take on it, I hope that I at least give the arguments their due. And, to the extent that I fail to do that, I think it's good to be called out on it. And I think it's a good opening for just a conversation we can have about this for sure. So excited to do that.
Yeah, I mean, we have a policy and safety section for a reason, right? Because even if you don't believe in X risk, I think it's fair to say, just based on all the stuff we discussed, that there are various potential negative outcomes related to AI, some of which are more near term and certain, like we've talked about with, spammers or these phishing calls, right? It's already happening. Yeah. And we already need some regulation or some technology solutions to deal with that. And then you have more, sort of hypothetical scenarios that you probably still want to think about and potentially use some things about.
And I think it's also true, I wouldn't be surprised if AI safety writ large was an election year issue. So, to the extent that you're following AI policy stuff and AI safety stuff, I think that becomes the zeitgeist. We're already kind of seeing it. So, just to cover it, I think is just a good thing for people's general awareness.
Yeah. Anyway, thank you for the feedback. We will try not to be too tilted toward existential risk, or at least have our 2 opposing viewpoints. And thanks for the couple of 5-star reviews. Someone said, want to know what was found in Pandora's box last week. So I guess AI is a Pandora's box now. I don't know. But anyway, so this week we're going to have kind of no super big stories, but some interesting trends. So for business, we'll talk a lot about hardware this week, just a mostly chip hardware type week. We'll have some discussion of an open source model from Alibaba that is potentially taking on Llama 2. And then in research and advancements, we'll have some pretty cool stories about these language models using tools, which has been kind of a trend for a little while. And then our usual mix of, policy and safety and synthetic art. Starting with tools and apps. First story is ChatGPT gets several new features, including multi-document chat. So I think even just last week we mentioned how it got some features of custom instructions. Now there are a couple more things that you can actually see if you just use ChatGPT. So there's these little suggested chat responses where you like the AI tells you, I guess, some things you can say in your chat as suggestions. And there's this chatting over multiple documents. So you can, I suppose, upload files to chat about, and now you can upload multiples of them. So if you, I don't know, have multiple emails you want to read through all at once, you can now do that.
Yeah, I think the multiple document review thing is really interesting. It's, of course, not the first time that we've seen, an LLM do this sort of thing. Anthropic and and Google Bard, that is, have related features. But it's one of those things that I think is actually pretty fundamentally paradigm breaking. Like we're used to, when we interact with the internet and do search, like we type something into Google, we get a bunch of documents. But what we can't do is, I think I saw Anthropic phrase it this way: talk to your documents. So there's something here about it's more than just like a database search or a term search. It's really this like semantic thing where, upload maybe a ton of emails or maybe upload PDFs, and the context windows are now getting so big that you can handle really big documents. So I think it's kind of interesting, and I wouldn't be surprised if we see some really cool use cases, especially in things like sales, where you just need a ton of context on a given customer. And if you upload that email thread, like you said, Andre, and like their history of payments and, any customer support tickets they have, you can start to really automate and scale the sales experience.
Exactly. Yeah. I can easily see this becoming sort of part of your workflow. And in some ways, I've seen this myself for programming. Last week, I had this kind of long chat with GPT-4 where I was using this new testing framework and I needed to write something kind of obscure, like a particular configuration to gather some statistics and print some stuff out. I Googled around for the documentation and Stack Overflow, and it was all kind of ambiguous. And then I, asked GPT-4, it generated some valid code. Then I went back and forth with it for a while, and it made various mistakes. I had to correct it on some pretty obvious stuff, but still, it's still a little mind blowing how it can just be part of your workflow that saves you hours of time on a single task.
Yeah, it's also and we've seen this talked about. I think it's some papers that we covered earlier, but how there's this almost exchange rate between fine tuning and then prompting, where the way, when you feed a prompt to ChatGPT or one of these LLMs, the way that their behavior changes, it's as if they were fine tuned in a sense. There's some exchange rate of the processing power that goes into fine tuning versus inference in that sense. And so this is kind of, in a way, it's a step in that direction where, you upload your documents almost like you're slightly fine tuning the model on your own use case. So you're really starting to get much more into the domain of customized agents, personalized agents for your use case, which blurs the distinction between a lot of the stages of model training and deployment. And I don't know, I think there are just a lot of really interesting questions about use cases here.
Mm-hmm. Yeah, so some cool new features for ChatGPT. Next story, Tinder tests AI photo selection feature to help users build profiles. So that's a story. Tinder is testing this feature that looks at your photo album on your phone and selects the 5 that best represent you for your dating profile. And if you don't know, Tinder is a dating app, one of the really big ones. And the idea here is that this would make it faster to build a profile instead of having to manually pick all your photos. I could see this definitely being used by lots of people.
Yeah, it's also really interesting ethically. So you think about the scenario, they're also talking about using eventually generative AI to help people write bios. And you think about you're interacting with this profile. It was written by AI. The person behind the profile easily could be not the best writer, and yet they present themselves to the world in this way. The ideas they share may not even be necessarily, at least in the way they're expressed, may not reflect the way they think. And it's the kind of thing where I imagine, like these apps that help people get set up for like marriage or whatever. And I don't know if Match.com is maybe more in that direction or something. I can imagine them being more reluctant to do this because, like, you don't just care about that initial attraction, which maybe Tinder indexes more towards, but you care more about, like, okay, who is this person? Are we compatible? Like those deeper questions. And so I'm really curious, like where that line's going to be drawn, because we've already seen like people photoshopping their pictures using old pictures, and everybody gets pissed. Like, you're wasting my time. I show up and you're like, a completely different person. That in the domain of writing, that in the domain of eventually image editing and modification, like, I don't see that playing out as well on like a Match.com as on a Tinder. And it's interesting the kind of incentives of the platforms and how they play into their use of generative AI.
Yeah, I think you can definitely get into some kind of questionable territory if you can have a lot of text and you just kind of auto-generate it from some seeds that is already kind of not necessarily representing who you are in the same way as it used to be. But this particular feature, selecting some good photos of you from among all your crazy amount of photos, if you have that, yeah, it's a nice thing, and it's kind of one of these things that is kind of crazy to try and imagine implementing, because it has to basically look at photo quality and like, is this a good headshot, blah blah
Yeah.
blah. In the past, it would take a while to build, and here I can imagine them. Uh, Probably it's still a custom model, but now with some of these off-the-shelf models, you could even just use a text prompt and could build this in like an hour. So that's where we are.
Absolutely. Yeah, no, sorry. The reason I was talking about the text was, I think the article does say that their CTO is explicitly like looking at using text generation for bio writing purposes. So, more and more the profile starts to become an interesting hybrid. I mean, that's really what we're talking about. And ultimately, we kind of are going to be hybrids of our online AI personas and like whatever our base personality is. So who's to say what's honest and what's dishonest in this strange, murky world of ours? And next up, we have GitHub Copilot can now tell developers when its suggestions match code in a public repository. So if you've ever used GitHub Copilot or a similar kind of code writing assistant, you know that sometimes, pretty rarely, but sometimes you'll get code suggestions from the app that'll match code that already exists on an online repo. And for various reasons, that may be deeply undesirable, right? If it's matching code from a repo that is, has a non-permissive license or something, you may want to know that. You may not want to actually like just use that code as it's presented to you. And so this is basically about the launch of a new tool that allows you to turn this like code referencing tool on. So now you can, in GitHub Copilot, turn on code referencing, and it'll tell you essentially if there's any matching code in what it's generated, code that matches stuff that's already online. So useful for attribution and for understanding as well the provenance of the data behind Copilot too. So a little bit more transparency maybe coming from the whole Copilot ecosystem.
Yeah, and I think this has a particular importance if you do care about licenses. So a lot of the code, famously, when this was first trained, there were a lot of discussions of it basically just scraped GitHub regardless of license. Maybe they cleaned it up now, but regardless, right, if you're writing commercial code, some of the public code on GitHub is not licensed to be commercially used and has stipulations in its license of like, you need to attribute your code source. So maybe as a next step, if you can already attribute it to the actual repository, you could also have a sort of license check of like, can I actually use this for my commercial application? And it's kind of showing how slowly but surely we are figuring out how to use generative AI in a way, right? Where there's all these kind of questions of what is the legal kind of usage property here of if it's trained on some data that is open source, or that Isn't it even public? Can you use this? I mean, this is one kind of straightforward answer for code generation of, if you can find that it's somewhere and there's a license associated with it, then that's a pretty clear-cut case of don't use that code just because the AI spit it out.
Yeah, and they do say in the article that like right now, so this is, by the way, in private beta, so they're gradually rolling out the release, but they flag that you can't currently see results that match specific licenses. So in other words, you can't just say like, hey, give me autocomplete, but like code autocomplete, but only propose code that's like on an Apache 2.0 license or something like that. But they're saying that they're actively looking for feedback to see if that's something users are asking for. I mean, to your point, Andre, I'd be really surprised if it wasn't. Like, it just seems like the sort of thing that you naturally care about if you're writing proprietary code. So I don't know if this is like, they surely must be looking into this, at least internally. But
moving on to applications and business. First story being CoreWeave raises $2.3 billion in debt collateralized by Nvidia chip. CoreWeave is a specialized cloud provider, and it has raised all this debt to expand its infrastructure and meet rising AI workload. It's kind of this trend, I suppose, of raising debt in this private asset-based financing kind of setup. And, if you have NVIDIA chips, I suppose that's a good way to raise some money.
yeah, I found this just friggin' fascinating. So CoreWeave, we've talked about them before, right? They kind of went from zero to hero like in the last 3 months. Like I hadn't heard of them, I'll be perfectly honest, like 3 months ago. And now, they got a $2 billion valuation. They're backed by Nvidia. Apparently they have something like 45,000 GPUs in their stock. So this is like a well-armed arsenal of GPUs. And one of the really cool things about this is, you imagine essentially what they're doing. They're collateralizing their debt with these GPUs. They're saying like, look, if we can't pay back the debt, at least we've got this hardware that has value that the bank can come and take in the event we can't repay. And like, there's a whole bunch of fascinating stuff that comes with that, right? So first of all, that collateral is only worth as much as it's worth as it depreciates. So like GPUs, they may be super valuable today, but Moore's law, the efficiency of these systems goes crazy, and the GPUs from 4 years ago are just they're not really as competitive nearly as the kind of H100s or even A100s that we're seeing today. So you got to think about like, what does the schedule look like for depreciating these assets? That's been a big part of the story as CoreWeave tries to figure out like, what is the right way to price out these assets? And the people underwriting the loan have to do the same thing and be like, okay, what's a reasonable depreciation rate? So essentially, this boils down to a kind of gamble on the basis of a couple of predictions. Like first off, the CoreWeave has to be betting that these things will hold their value over time. And the bank does too, of course. So in a sense, they're kind of betting on the GPU shortages that we're seeing, maybe extending into the future and this old hardware still being valuable in the future. And then, you're also looking at, maybe as cutting edge systems are used to train cutting edge models, you're still going to find value like we do today in older GPUs being used to maybe just run inference with more standard models, kind of less impressive models. Something we do see, but it's just this interesting moment where the technical nuances of the hardware story in AI become directly relevant to banks, directly relevant to private equity and all that stuff. So I just thought this was really, really interesting. Oh, and sorry, one last thought. I saw this on Twitter. I thought I had to share. So there were a couple of like pessimists looking at this deal skeptically. And they were like, well, I don't think they should really be doing this because think back to Sun Microsystems. We've seen this before. And I was like, Sun Microsystems? That's like an old timey thing that I haven't heard since the 90s. What is this? So Sun Microsystems tried this basically back in the dot-com days. They engaged in this practice that was known as server securitization. And basically, they used their servers as collateral. And they had this whole scheme, this debt instrument that was called an asset-backed security. It's exactly what it sounds like. It's exactly like this. So the challenge was that when the dot-com bubble burst and technology spending dropped, Sun had just challenges generating the lease payments from its customers that it needed to kind of keep everything keep everything afloat. And so the servers lose value, people are less interested in using them, and the collateral declines in value. And I think everything just went to crap for Sun Microsystems. So bottom line is, these bets actually do have an impact. And if we saw a general crash in the use of AI systems and the value, therefore, of GPUs, loans like this would become pretty tenuous. So anyway, I just thought this was fascinating. No one's really tried this before at this scale. So kind of a cool situation.
It is an interesting story, and it speaks to us related to some of these things we have in addition. So the next story is Nvidia GPU shortage is top gossip of Silicon Valley, and I found it kind of fun that there's an article highlighting this gossip. But yeah, it is top gossip in Silicon Valley, with companies trying to get access to kind of the most high-end H100, A100 GPUs for using large language models, or in many cases image generation models. And with big companies like OpenAI and Inflection, Anthropic, Meta, trying to get hundreds of thousands of these GPUs, like spending billions of dollars on GPUs, it's very true. Now it's getting not so easy to give Amazon your money to use these GPUs on the cloud. There's quotas, and there is some competition to actually be able to even have the hardware to do some of these things.
Yeah, and I think it's one of those things where it's like, it's always good to kind of have a scale in your head of like what's big when it comes to numbers of GPUs. And like, what's big in this industry is in the tens of thousands when you look at H100s in particular. The author of this post that is the gossip that's going around apparently. He's like speculating that OpenAI might want 50,000 H100s. Inflection might want 22,000. So these are kind of the numbers that you think about. They already have obviously tens of thousands as well. And also just a flag when he says OpenAI might want 50,000. I'm a little unclear as to whether they want them themselves or they want them via their partnership with Microsoft, because Microsoft's really been providing them with the compute infrastructure. But anyway, that was kind of cool. And they talk about CoreWeave too. CoreWeave's sort of like everywhere now in all these posts. They're talking about their crazy growth and going from 30 million in revenue last year to 500 million this year, 2 billion anticipated next year. It's just insane. Definitely very interesting kind of ecosystem and moment. A last observation I thought was interesting in this post. They talked about the idea of the GPU shortage, and in our heads we all imagine like if there's a shortage of GPUs that I can use to train my models, it's like this physical piece of hardware. And while that's true, they kind of add a little nuance here. They say, when we talk about GPU shortages, we're talking about a shortage of some components on the board, not the GPU itself, not the processing unit itself. But apparently what they're seeing is, they don't specify, but components other than the GPU itself that are actually the root cause of this. So it's not clear, but it could be stuff like, there's like clock generators, there's PCBs, there's cooling components. Like it's not clear which ones are the source of the backlog here. But I thought that was kind of an interesting level of extra detail that you don't usually see.
Indeed. And actually, there's yet another related story this week where the vice president and general manager of the DGX system at Nvidia actually addressed this topic and discussed why there is a shortage. The shortage, as you said, is not to do with the chips per se. It's more about the bottleneck being in manufacturing enough GPUs that deal with all this demand basically, and the chip making is there, but they need to package the technology and combine these various components on the GPU. That takes time, and they're you just can't make 10,000 GPUs very quickly. And it mentions how Elon Musk apparently procured 10,000 of these GPUs, right? So when you have orders like that, it's not too surprising.
Yeah, and I actually think this is like a useful thing. And anybody involved in like policy or interested in the idea of these shortages, like understanding that supply chain, like what goes into making a GPU that sits on a server rack somewhere in the Nevada desert, is like it's pretty useful, because it is such a complex beast. I don't know if it'd be useful to give like a 30-second overview of it for context, but like, yeah, is that cool? Is that, I'm not going off?
I think it's good to know.
Yeah. Okay, so roughly speaking, like you start off with the designers, the kind of GPU designers, or the chip designers. These are companies like Nvidia that will design their next like card. They ship those designs off to the chip fabs. So this is like typically like Taiwan Semiconductor manufacturing company, TSMC, or Samsung or Intel, but TSMC is like the big global leader. They actually make the chips that are needed. And then, as Andre said, there's like this next step after that, which is packaging. And usually what happens is the chips have to be sent from like the foundries in like TSMC in Taiwan or something they're packaged, I think it's like usually in like Vietnam or areas like that. They'll package them up according to whatever the original NVIDIA specification was, let's say, and they get shipped back. And then you have the data centers that actually stock full of these GPUs. And so you can have bottlenecks at any one of those stages. They all involve really specialized stuff. And for a while, TSMC was a key bottleneck in this whole thing. That had to do with this weird COVID era thing where all of a sudden everybody like canceled their orders on them. And long story short, it's just like really, really hard to make chips, and like revving up production is this incredibly capital intensive thing. So when you cancel a bunch of orders, it's not like you can just re-rev up production. That has a lasting effect. But so now what we're seeing is like a delay at a whole other stage, which is the packaging step, and that's where all these extra components that fit on the GPU board show up. So anyway, long little rant there, but
yeah, good overview, right? It's interesting to know, given how important of a topic it is for AI. It's worth understanding that it's not very easy to just ramp up production, because it's this whole worldwide process. You need to make these complex chips, but then you have tons of components. So anyway, it's there's a reason for the shortage. And we have yet more stories on it. So moving on to the lightning round real quick. One of the stories is that NVIDIA's AI GPUs are selling for up to 70,000 in China. So things like the H800, the most high end. This is presumably affected by the restrictions on GPU exports. So the H800, I think, was the kind of special made GPU that is meant for the Chinese market. And these cost in the US 30,000. But yes, in China, there's even the same problem of supply, and they're going for a lot.
Yeah, it's kind of insane. Eh? They say it's even hard to get them at 70K. So pretty wild. The H100, by the way, is like kind of like you're saying, the nerfed version of the H100, which is the one we were talking about a few minutes ago when we were talking about all these companies trying to get their hands on these GPUs. It's nerfed in the sense that the interconnect between the chips has been, like, basically the communication between these chips has been reduced, the bandwidth. And that makes it harder to scale big clusters of them. So the idea is to prevent Chinese companies from being able to make really scaled runs. For various reasons, that doesn't actually seem to be an effective counteracting strategy for scaled training runs. So probably the Department of Commerce will have to tighten up their GPU export controls again. But for now, the H100, this nerfed thing, is going for $70,000. That is insane.
Yeah, I wonder, having just discussed this question of manufacturing, right? If you develop a whole chip that is a nerfed version, now you need to manufacture it in addition to things like H100. Maybe it's easy to reconfigure things just a little bit, given this interconnect kind of difference where it's mostly the same still. But that is one of the levers the US could pull in general, is making it harder for other nations to compete based on hardware shortage.
That's true. And like one last note on that 70K, actually, come to think of it, that's probably an underestimate of the effective price that they're going for. Because we have talked about in the past that there's a lot of GPU fraud in the Chinese market where people are kind of pawning off like kind of shitty, not actually H800s as H800s. So if you think about that fraud as an extra tax on the purchase that you make, the extra research you have to do, and the fraction of the time that you're going to buy a dud, 70K might actually be a decent underestimate. So anyway, kind of a remarkable delta there.
Mm-hmm. And related to that, we have a story. AMD considers making a specific AI chip for China to comply with export controls. So that's what Nvidia did, and Intel also did that. Now the CEO of AMD, Lisa Su, stated that they may consider it to be compliant with U.S. export controls. So really goes to show how impactful these export restrictions are, and how, regardless of them, these companies still will want to offer their products in China.
Yeah, and how central, right, the whole Chinese gambit is for these companies. Like I think in the article she said, Sue that is, said that AMD is anticipating around 50% growth in the second half of the year relative to the first half, thanks in large part to this new chip. So like these are not small bets for these companies. And you can imagine the lobbying efforts and the and the hopium that goes into this. All right, and next up we have actually kind of a close to home story for me because I'm, a hockey playing Canadian. AI chip firm Tenstorrent raises $100 million from Hyundai and Samsung. And so just a quick thing on Tenstorrent, because this is actually an important bit of context, I think, for people to understand given the state of the compute situation. So Tenstorrent takes a pretty, they're a GPU, roughly speaking, like a kind of compute company. And they have a multi-core processor that they build that's a little different from the traditional processor. So usually in usual GPUs, the cores communicate with each other and they share data through a kind of like a shared memory space. And the difference with Tenstorrent processors is they communicate between each other directly. So instead of relying on a shared memory space in what's known as DRAM, like dynamic random access memory, Tenstorrent processors have a network communication hardware that's built into each processor. So they all talk to each other directly without using any specialized communication pathways. So it's a pretty interesting differentiated strategy. They've raised this big round because of the massive interest in getting compute. We've just talked about people are struggling to kind of get their hands on that sweet compute. And they're headed up by a guy who's a Tesla veteran called Jim Keller. He took over apparently earlier this year. I hadn't heard of this before. And they're taking on essentially Nvidia. You can think of them as an Nvidia competitor, designing their own chips with this kind of unique strategy.
Yeah, interestingly, the investment is led by Hyundai Motor Group and Samsung. So, obviously players that need AI chips, in particular Hyundai. There was some talk of using this technology to enhance AI capabilities in vehicles. It's quite a bit of funding, but given this is hardware, and that's all we've talked about so far, it makes sense that there's kind of some funding to maybe get an edge in that space. And speaking of vehicles, we actually do have a couple stories that don't have to do with chips for the remainder of our lightning round. First, we have Cruise begins testing self-driving vehicles in Atlanta. That's the story. So Cruise has been testing in San Francisco for quite a while. It's one of the main companies that actually has self-driving cars out on the streets without drivers, and you can actually call them from an app. They have also expanded to Nashville and now Atlanta. And Atlanta is a major city. It's not quite on the scale of New York, but it's, I don't know, huge, right? And it has some crazy traffic, as you would expect in things like this or in SF. So just, is part of this trend of both Cruise and Waymo sort of expanding slowly but surely across the country.
Yeah, and you're really right, that slowly but surely piece, right? You might think, hey, they launched in San Francisco, they're safe in San Francisco, so what's preventing them from just launching nationwide? And of course, it's these ridiculously long tail edge cases that show up when you're doing self-driving car stuff. So if the weather's slightly different, the climate's slightly different, you run into weird weather patterns the car hasn't seen before. So it makes perfect sense that they're doing this cautiously. It's been interesting to see too. Cruise and Waymo definitely taking the lead. I don't think I've heard of like Tesla making similar leaps, for example, in anything like this way.
It's interesting to think back, 5-10 years when self-driving car was going through this big boom as an industry, and you had many players all coming in and developing their own technology.
Yeah.
And then now basically two of them have wound up staying alive, right? With Cruise being this Y Combinator startup that I think was eventually kind of invested in by a major car player, and Waymo, of course, being a spin-off from Google.
Well, yeah, I think Cruise now is just a GM subsidiary.
Mm-hmm. Last story, also on self-driving cars. Toyota and Pony.ai plan to mass produce robotaxis in China. So, as with many technological trends, there are these companies, Cruise and Waymo, that are doing self-driving cars in the US. And they are completely different companies, at least some completely different companies that have been doing it in China. And Pony.ai is one of these companies that has been operating in China and is, as far as I can tell, the leader there on that front. And we've talked some time back on how they are starting to test also on public roads and things like that. So yeah, Toyota and Pony.ai plan to mass produce these things. Toyota has already invested hundreds of millions of dollars. So it seems that they are making this similar push to Cruise and Waymo here.
Yeah, I'm curious about what the expansion rate is going to look like for these sorts of companies in China, just because of the different risk tolerances of the different cultures and governments ultimately to crashes and things like that. Obviously, so China. This may not be obvious, but China has historically this problem with institutional memory on accidents and catastrophes, where things tend to be suppressed if things go really bad, and so the public is not as aware of this history of industrial accidents or other, say, COVID type situations. And so that has historically fed into public appetite for risk on stuff like this. So I'd be really curious how that affects the rollout. Are we going to see faster, more aggressive rollouts or not?
Indeed, and I think it also parallels in some ways. If you go to China, at least from what I've heard, in some ways it's sort of very strange coming from the US. You would assume that things operate the same, but
Right.
the ecosystem with respect to, for instance, smartphones is very different. You have one app that sort of does everything, WeChat, which is unlike the US. Mobile payments are huge. It's sort of like the default. A lot of vendors don't take cash anymore. So in some ways, China has embraced technology and moved faster than the US. And this could be another instance of that.
And kicking off project and open source, we have Alibaba rolls out open sourced AI model to take on Meta's Llama 2. Okay, so obviously Meta came out with Llama 2, it feels like 20 minutes ago, but that's AI time, I guess, a couple weeks ago now. And Alibaba, not to be outdone, is coming out and open sourcing. So these are not, based on the article, it's a little unclear, but I don't believe this is actually a new pre-trained model. It seems that it's a derivative of a model Alibaba made earlier back in April. It was called, and I'm going to butcher this, but Tongyi Qianwen. And so it came with multiple versions with multiple parameters. And now they're actually open sourcing Qwen 7 billion, which is a derivative of that original one, and Qwen 7 billion chat, which is presumably a dialogue fine-tuned version of it. So the idea is essentially to just allow businesses to start using AI. And I think if I'm reading this right, and this is a little hard to process, to be honest, but I think this is actually more of a model compression and distillation story. So they took this big model and that they built back in April, and they compressed it down and then open sourced that. I will note just a little interesting error in the article itself. The article says that this apparently marks the first time a big Chinese tech company has open sourced its LLM. And I don't know if that's quite true. We've had GLM like 130 billion come out, 130B come out like, I don't know, a few months ago. CogView, like there are academic institutions involved there, but there is overlap with private companies as well. So yeah, I'm not so sure about that claim because there are a lot of Chinese companies that have done some open source stuff in the LLM space. But either way, I think really interesting. And if nothing else, a story about compression and distillation of existing models to make them smaller and to make them therefore usable by the average company that can just like download the 7 billion parameter model.
It seems like a real sort of response to Meta in a way, right? I mean, not just because of the timing, but because Meta as a company has been pretty insistent on this open source push. So here, to me, it feels like a little bit of a half measure, perhaps, of only releasing the 7 billion version to open source something and in a way kind of follow in Meta's footsteps, but at the same time, not release the biggest one, the best one. So 7B is pretty small. It's the smallest version of Llama 2, for instance, you can get. But it is fully open sourced. They released the code, the model weights, documentation, and anyone can use it, researchers, commercial institutions, unless you are a company with more than 100 million active users, in which case you need a license from Alibaba, which is related. It's similar to Llama 2, which famously said if your company has over 700 monthly active users, you can't use this. You don't have our permission to like generate training data or something to that front. So yeah, it's funny how this has become like a standard thing of, if you are actually a competitor, big company, then don't use this. But anyone else, feel free.
Well, I really wonder. I mean, obviously, there's like corporate strategy that plays into exactly what that cutoff is. But technically, interesting to note, this makes their model slightly less open source than Meta's model because the bar is lower or higher, lower. Anyway, it's just like you got to be a smaller company to be able to use this. So kind of an interesting rule.
Moving to research and advancements, first story is introducing AudioCraft, a generative AI tool from audio and music. This is from Facebook. And yeah, it's this tool that generates high quality audio and music from text. It seems to be a combination of 3 different models: music gen, audio gen, and encodec. You've seen in the past, actually, with audio generation, often it seems like it's a combination of models as opposed to one big model, which is what large language models are. So in audio, you often need to generate these like tokens, and then you need to go from tokens to spectrograms, and it's just a little more complex. And here they showed this new tool. They have a website where you can go and listen to some of this generated audio. As is kind of generally the case, still you can tell a little bit that it is AI generated. So there's some examples of, like, for instance, you can tell it mellow hip hop, vinyl scratching, deep bass, and it generates something along those lines, but it doesn't sound quite real yet.
Okay, you found that like it wasn't. How long are the clips, by the way, that it can generate?
They say they have a kind of long term consistency. So they say, probably minutes at a time. Their examples that they released are not that long. It's, like maybe 5 seconds per prompt. So hard to say. This is released for academic use. So researchers can train and build their own models based on these music gen, audio gen, and codec.
So this is a very meta play in like 2 ways, right? One with the multimodal thing, because Meta loves to do multimodal, and then it sounds like the other in terms of the academic release of the model too. One thing that comes to mind is like with audio models like this, music generation models, I wonder if there's an advantage to having like a slightly shorter context length and getting them to continue to generate past their context window. So this is just me speculating, because that's kind of like what you get with a DJ when they try to seamlessly blend from like one style of music to another. So you kind of like lose context in a seamless way. Anyway, sorry, I'm not a DJ. I'm not qualified to say this. You shouldn't be listening to me, but it sounds like a cool idea.
Well, yeah, and they specifically point out that they hope that musicians and sound designer can use this to find inspiration and iterate on compositions. They released this under actually the MIT license, which is very permissive. So as with Llama 2, this can be used commercially, as far as I understand. So they seem to really be saying basically, okay, here's some models for audio, of which there's not quite as much open source stuff. And generally it's a little bit harder because there's no data. You can't just scrape the web necessarily for text and music pairs. So this is definitely kind of a pretty big deal if you're working on audio generation, as far as I know.
So what do they do for data, by the way? Because I guess they'd worry about copyright quite a bit. And do they just...
So they use several data sets, just a whole bunch of them, actually. Audio set, BBC sound effects, VGG sound, a lot of these. And they have their own annotation. I think they paid a bunch for all of these things. So it's a real mix of different types of things, it looks like. And it feels like they cobbled together everything they could and then paid for creating text annotations for this to basically build their own data set.
Interesting. And next up, we have ToolLLM, facilitating large language models to master 16,000 plus real-world APIs. Okay, so we've talked about instruction fine-tuning on the show a lot. You take a language model, you fine-tune it, get it to follow instructions. We've talked about tool use a lot. I think we've already talked about it on this episode. So this is like taking that to the max. Basically, this idea is like, in most of the research that's been done so far on tool use, people train these language models to use either a limited set of real-world tools, or they use like kind of very abstract tools that don't really exist, but just to prove that they know which tool to use. And so this challenge of how do you get a large language model to know like which real world tool to use when it can choose from like thousands of tools is, well, still an open challenge. And so this paper tries to address that. It tries to address it in part by creating a data set that they call ToolBench, which basically has a bunch of different examples of tool use trajectories, like sequences of tool uses that a ChatGPT bot goes through that can then be used to then train another model to kind of use tools really effectively. And it's sort of interesting how they do this. Like, one of the main challenges that they face is that if you want to get to have your model like use multiple tools together, you're not going to find a data set anywhere out there where there's enough multiple tool use with interactions between, like, if you got 16,000 tools, there's tons of tool-to-tool interactions you have to account for. And so what they do is they say, okay, let's go to this database called Rapid APIs, basically like a place where you can find a ton of different APIs. And Rapid API has this like kind of hierarchical structure. So you have categories of tools that are most often related to each other in functionality and goals. And so what they do is they'll like randomly select a small number of tools from the same category and bet that there's probably some coherent thing you could do with those tools together because they belong to the same category. And from there, they use ChatGPT to create like an instruction that uses those tools, and then a solution, an actual kind of multi-step decision-making process that executes some task with those tools. So it's sort of interesting, I think, like a really impressive use case for ChatGPT. You can think of this a little bit as a kind of mostly a data collection strategy, and also they couple that with this new strategy to help the model reason through this kind of tool use process. They use what they call a depth first search based decision tree. So essentially, all this is they get ChatGPT to try once to solve for the instruction using these tools, and then if it fails, it'll like stop and try again, and it'll do another branch of the tree, and another branch until it succeeds. And this essentially allows them to collect a whole bunch of success cases where it goes all the way through successfully using multiple tools together, and then they can use that data set to train new systems. And they actually do. So they fine-tune a 7 billion parameter version of Llama to train what they call ToolLLM, because we needed a new Llama derivative. And apparently, ToolLLM has comparable performance to ChatGPT, at least according to them on this subset of tasks. So pretty cool.
Yeah, pretty cool. It's one of these things where we've seen more and more the importance of APIs and tools as a complement to what language models can do. So language models are kind of amazing, but they are, limited to generating text. So they can't query the web, for instance, or they can't do things, right? Aside from generating text. If you have APIs, they can now do things, right? They can send, a request to Lyft to pick you up or something random like that. They can interact with services for retrieval information or for sending out requests and things like that. So it seems more and more like a kind of critical or one of the significant parts of how this technology will work. And one of the questions is, well, how do you scale to a lot of different APIs? If each website has an API, how do you actually deal with your language model knowing all of them? And this is one answer. You just have this approach to generating a data set. And then with that data set, you can train a new model or fine-tune a model, rather, that now can generate text with these API calls. And by the way API calls work is it's still just text, right? It's still just some code. Yeah. In the back end, as a user, you don't see what's getting generated, but there's like some special text. It's like API call and all of that. So, and a nice little continuation of research on this front.
Also, I think an interesting trend that we've seen before, right, with ChatGPT being used to like generate data that's used to train another model. So like proprietary models getting used to generate this data, and then the open source community kind of feeding off that. So anyway.
And moving on to the lightning round, first story is very much relevant. We have tool documentation enables zero-shot tool usage with large language models. So this is pretty much the opposite approach of, instead of training a model, you have this zero-shot thing, which is basically saying you have zero examples to train from. You can't actually see any examples of how to use this API, but you can document the API and explain how to use it. And this paper kind of explores that option and shows that it is sufficient, apparently, to actually be able to use the tool, which bodes well, right? Because if you introduce a new API to whatever your tool set, you can't just continually retrain your model if you have many different APIs being introduced every day. So this could be part of a solution, is instead of being trained to use it, instead of having to have examples provided, just document the API and expect the LLM to figure it out.
Well, and it's very much in line with what we were talking about in the, I think it was the application and business section earlier, with ChatGPT allowing multi-document search. Essentially, that's what this is, right? You're uploading a document. It's as if you upload, say, the documentation on a new coding library. And now it knows about that coding library. And so if you then ask it a question about how to code using this library or using this new tool, it will presumably be much better equipped to do so. So I think this again, you're absolutely right that this is at the opposite end of the trade-off that we've seen. Like, do you fine-tune a model, or do you prompt it with documentation that gives it more context? And earlier we were talking about this idea that actually those are kind of the same thing. like ultimately, when you look at the math behind it, it turns out that prompting and fine-tuning are mathematically at least analogous, that there's a deep analogy there. And so you can almost trade off the processing that happens on the prompt for the processing power that would have to go into fine-tuning the model. And there's some exchange rate between the two. I think one of the dimensions of research that's going to be most interesting to track in the next few months and years is, what is that exchange rate? How do you trade off between fine-tuning and prompting? When do you choose to prompt in exactly this way, as this paper does, versus when do you choose to actually fine-tune? I think the answer right now is pretty kind of ambiguous, but I would expect a lot of people are going to be working on this. And next up, we have open problems and fundamental limitations of reinforcement learning from human feedback. And so if you've been listening to the podcast in the past, you've heard us talk an awful lot about reinforcement learning from human feedback, or RLHF, or RALPH, as its friends call it. And it's this tool that essentially takes a language model that you pre-train, so basically like your GPT-3, GPT-4, whatever, and then it gives it an additional layer of training, this fine-tuning stage, where it's trained not to predict the next word, not to do autocomplete, which is what the pre-training usually does, but rather to obtain a high score based on human feedback, roughly speaking. And there are a bunch of challenges with this approach that people are concerned will not allow it to generalize to artificial superintelligence of the sort that increasingly labs are expecting might come in the coming years. And so this article basically looks at, okay, what are some of the big blockers here? It breaks them down into blockers that are like issues but resolvable, and issues and blockers that are considered more fundamental. And just to give you a quick idea, some of the fundamental ones are like, if you're going to rely on human feedback to evaluate a model, for example, to verify that it's being truthful, not manipulative, not making plans you don't want, one challenge is humans can't evaluate difficult tasks terribly well. Like, we might not be smart enough to actually evaluate how it's performing at a task. Humans can be misled, so evaluations can be gamed. You can have a language model that can, imitate the persuasive and manipulative tactics of humans, and we've actually seen that happen in the GPT-4 evaluations, for example. And there are other problems, like an individual human's values don't necessarily map onto the values of a diverse group of humans. So, like, if you're doing RLHF, you're using a single human's input at each stage, but like that single human may not represent a broader human population. And then another one was this idea of reward hacking. So you can always optimize, if you're the AI, you're really optimizing for being convincing to humans, not for solving the actual problem. And that's kind of the perpetual problem with a lot of these fine-tuning schemes, is we're fine-tuning for proxies of what we want, proxies that we can actually program into the system rather than necessarily what we deeply want. And then they also flag this idea of power seeking, which I'm sure we'll get to if we talk one day about AI alignment stuff. But it turns out there's a bunch of research that's been done on the idea that as you make systems more and more capable, they tend to converge on so-called power-seeking behaviors. They look for states of high optionality. And so the worry here is that RLHF does not actually do anything about that tendency. And so you still are left with this system that has all those incentives implicitly baked into it. So that's kind of quick overview. Lots more to say there, but maybe I can park it from there.
It's a good overview paper. It does highlight those limitations in a nice sort of, I think, 10, 12 page summary. It also has some good suggestions and kind of things that may be used to address these challenges that I liked. There's color coding in the paper, which is kind of cool. I like that.
Yeah.
And it points out that, even aside from technological questions, of which we are quite a few, and there's a lot of research that's ongoing with these highlights, there are questions of governance and transparency. So aside of just the technical question, in addition to that, there are other tools at our disposal to make sure that things don't go bad, like having good incentives, having transparency and auditing, right? Kind of trying to check if there's a misspecification or if there's an issue with the data, right? Instead of just trying to get the algorithm to work. So there's no simple answer. There's a lot of, as you said, fundamental algorithmic limitations to just doing this particular type of algorithm that likely will mean that we do want to modify it. But there's probably a need for a combination of tools instead of
Right.
kind of just using this one tool as the alignment technique, as a thing that says, do what you want. It's a very powerful tool, it turns out, but by itself, it probably isn't sufficient. And if you look at, even OpenAI now has profanity filters and things like that, just because this by itself is not quite reliable enough.
Yeah, I think that's a really good observation. Like the solution does not look like a silver bullet. It probably looks more like many, many patches. And I think they make that case in the article too. It's like they use the analogy of Swiss cheese. It's got a lot of holes, but anyway.
Next story towards generalist biomedical AI. This is about MedPalm Multimodal, MedPalm M, which is a proof of concept generalist biomedical AI system that can encode and interpret clinical language, imaging, and genomics with this one model. And it has this multi-med bench, which is a benchmark with 14 diverse tasks, such as medical question answering, image interpretation, report generation, things like that. And it works really well on all of them. So it is compared to models that are designed specifically for each one of these tasks. And this generalist biomedical AI turns out to be able to solve all of them, kind of as a proof of concept.
Yeah, there was like one kind of wild quote. I was like thinking to myself, man, imagine, 4 years ago, somebody tells you, hey, in 4 years, we'll be reading this in like a paper from like an actual like super competent AI org. So they say these advances enable the possibility of building a unified biomedical AI system that can interpret multimodal data with complex structures to tackle many challenging tasks. And like, I don't know, just like like it's so easy to just gloss over that and be like, yeah, of course that's where we're at in the era of like, GPT-4 and stuff, but still pretty incredible. They also highlighted a bunch of examples of zero shot generalization to novel medical concepts and tasks. So basically, like as you scale the system, it seems it learns to solve new medical problems that were not in its training data explicitly, which is like that is wild. I think like another data point in the direction of scaling, solving a lot of these problems, and the amazing generalization ability of these systems, especially it seems when they're multimodal.
Indeed. Yeah, the highlighting of novel emergent capabilities is one of the cool parts about the paper. They say beyond quantitative evaluations of task performance, they observed evidence of zero-shot medical reasoning, generalization to novel medical concepts and tasks, and positive transfer across tasks. So it means that because you train on this variety of things, you kind of get better at each one of them as opposed to worse at all of them. So yeah, it's quite the notion, right? Medicine is one of these things that's not very easy, partially because of data, right? You don't necessarily have access to a ton of X-ray images, a ton of medical reports, and so on. So this is really showing how far Google and DeepMind have invested into this. They've been at this particular topic of medical AI for a while, and this is showing those dividends, I suppose.
That's actually that's a really good flag too. Like this is consistent with like the DeepMind philosophy, which is a little different from what we see, for example, at OpenAI, where they focus on like generalist systems. DeepMind seems to have historically focused on like solving specific kind of more narrow problems using a general approach. So focusing on like, medical problems or genomics problems with AlphaFold, or, like controlling nuclear fusion reactions and so on. So kind of, anyway, interesting that they're almost like zooming out a little bit with all of medicine here, but it's kind of hard not to do because their systems are so powerful.
Next, studying large language model generalization with influence functions. So this is an interpretability paper, sort of. It's about trying to understand how large language models work. And the idea is that influence functions identify which training examples contribute to given behavior at test time when you're doing some sort of output. I think this is interesting to highlight because this is coming from Anthropic. So it's one of these mega papers that's like 50 pages long, and it just came out. I have not read the whole paper, but it in the past, Anthropic has done some really, really good work on introducing new tools and ideas to be able to understand what a given language model is doing. How does it work, and how can I interpret some of its behavior? And this is a pretty good, cool example of a new concept for that space.
Yeah, it seems very much like at its core, an algorithm, like a fundamental algorithmic mathematical improvement, rather than necessarily like maybe a more conventional architectural thing, and definitely consistent with, yeah, like you said, Anthropic. Like they have this almost tradition now, starting with guys like Chris Olah, who would do what is now called mechanistic interpretability research, deeply understanding what every neuron in the network does. This is kind of an extension of that, where you're saying, okay, I want to deeply understand what the impact of this specific sample was, this training sample, on the weights, the values of the weights in my neural network. And so, obviously part of their interpretability program, how do we understand these systems better, looking for instances of deception and all that jazz. So yeah, really cool, more cool fundamental research, and another example for the annals of Anthropic does cool things, which we've covered on the podcast before. And next up, we're on to policy and safety, and we start with the AI-powered, totally autonomous future of war is here. And the title here, I got really excited is the wrong word. I got really interested by the title. It's, I will call it a letdown, but it's maybe more of an expose of a couple of what do you call them? Like little scenarios, little pastiches, if that's the word, that are blended together. Fundamentally, it's focused on the Navy's Task Force 59. So their mission is to integrate robotics into naval operations, and to do it really efficiently. They're responding to this realization that, hey, maybe making like a giant ass aircraft carrier that costs as much as a small city, but that can be destroyed by a bunch of tiny drones for $300,000 is not the greatest idea. Maybe we should be making things like drone swarms and kind of large quantities of smaller things. And it goes through this process of realization that people had within the Navy, that strategy might actually be both viable and maybe downright preferable. And so they're running a bunch of these experiments on various kinds of autonomous systems, minesweepers that look like surfboards, other kind of above water craft and things like that. So I thought it was a good general overview to understand where the Navy is coming from and how they're looking at this tech, and also the motivation behind it. They highlight in particular that back in 2014, the Deputy Secretary of Defense, Bob Work, he kind of was worried that the U.S. was losing what's known as overmatch, basically their ability to just absolutely crush any opponent who might rear their head, given the rise of China and Russia and so on. And they identified AI-enabled autonomy as the way to go to regain it. And so there's this very powerful top-down mandate that's really saying we need to look into this. And Task Force 59 seems to be kind of at the epicenter of this whole effort.
Indeed, this is quite a long article, so it goes into a lot of details with regards to this specific kind of effort within the Navy, and some of these kind of demonstrations of technology, really, right? So it's not, as you said, the title here of AI-powered totally autonomous future war is here. Well, it's still the future war, I don't know what you mean by it's here. There is some discussion of this notion of the autonomous part, right? So actually, I would say this is a misleading title in the sense that currently you might be surprised even there's very little on the front of autonomous weaponry out there. In fact, we had news stories coming, I think, last year, in 2021, of the first instances of an autonomous weapon, autonomous lethal weapon, that is. So there's been some contention with regards to There are these drones that could maybe be considered to be autonomous, but also they're kind of like loitering munitions, which is to say not very intelligent, right? They just sort of hang around, and if someone happens to pass by, they dive down and explode. So the line there was a little ambiguous of maybe it's not as fancy as autonomous technology. And they have some similar kinds of things here, where in theory, some of these surface vessels, submersibles, and kind of ships could autonomously engage and attack. But for the most part, that's not the intent, or at least, it's made clear that it's going to be a careful approach and not just deploying, military robots everywhere.
Yeah, I think you're exactly right. Like, when the one thing that I thought was kind of interesting in the story was, in the debate over should we and shouldn't we deploy these lethal autonomous weapons, or laws, as they're sometimes called, like there are two key axes that people point to as slippery slopes. So one is like the idea of this gradation, this continuum between autonomy and not autonomy. And you can kind of like play with it a little bit. You can creep up to the line. And so it becomes ambiguous. Okay, well, have you crossed the line or no? Is this an autonomous system or not? And so they do highlight some of these examples. There's like, remote control, and then there's like partial autonomy, and then there's full autonomy. And then likewise, there's another axis, which is like, how armed is this system? And they highlight a kind of, you can have a system that, okay, it just, it has a surveillance function, just a camera on it. Or like you said, a loitering munition. So now you're putting maybe a bomb on the thing, but it's not, it's meant to just respond if somebody walks into an area or something. And one of the cool ambiguous zones that they talk about was this like minesweeper system, right? Where they had like a boat going around that theoretically all it was supposed to do was like look for mines. But they talked about how they're like, yeah, maybe one day we put a machine gun on this thing to have it actually shoot at the mines. And it's just shooting at the mines, right? So that's all good. So it's kind of like you get into this whole thing of like, what is a lethal autonomous weapon? Like, what is that definition even? And when you're thinking about treaties, you're thinking about, different directives, or expanding on DoD's Directive 3000.09, which is kind of like the center of a lot of this stuff. This is, necessarily at the center of the question. So like, what is a lethal autonomous weapon system?
And you may be surprised that it's not really defined. I mean, last year we talked about how in the UN there were some kind of weak efforts to introduce some regulations on AI autonomous weapons, and those didn't go anywhere. Some countries, the US, didn't want to do that. The US and Russia, I believe, and a few other countries. So yeah, regulation-wise, there's still a lot to be done. And this is maybe one of the topics that I would say is maybe not seeing enough discussion, because we are ahead of a curve right now. There's not really that many autonomous lethal weapons, but they're coming, as this article points out. And that will have probably major implications, right? You gotta imagine. Next article, titled "So Important, UK Minister Endorses Google Training Drive in So-Called AI Arms Race." So the UK Science and Innovation Secretary Michelle Donlan has endorsed these plans by Google to provide basic AI skills training to workers and both bosses. And this is pretty much that. It's a training program that is important and apparently quite exceptional in its breadth. Not too much to say here, except this does kind of point to a general effort, it seems, by the UK to be a hub for AI, comparable to, let's say, the US, or just generally, attract a lot of talent.
Yeah, I mean, the UK has been super impressive on this stuff, including, the AI safety stuff. They're setting up this big AI safety conference, the Global AI Safety Summit, later this year, and it's become just the focal point of so much productive activity on that topic. There was sort of like this framing in this article that I thought it was kind of interesting to call out. They were framing Google's move here as a charm offensive in light of recent concerns about, among other things, job loss. And so they have a bunch of academics, professors who are coming in and basically saying like, look, Google's trying to control the narrative here. One guy said, I would like to see more warnings, the things businesses should be aware of when looking at AI, kind of like pointing at the downsides. Interesting that this is so multifaceted, and Google obviously has an incentive to train people in a certain way in AI. But it's unclear whether that's actually manifesting here, and they certainly do seem to have their eye on a lot of very important issues. So kind of an interesting bit of nuance and complexity when you start to think about, where the education's coming from and what the messaging is that different parties are putting out there.
Google certainly got at least some good PR from it. This is in The Guardian, so this I think makes Google look good.
Yeah.
But as you said, the UK notably not part of the EU anymore, so the regulations of the EU AI Act don't apply in the UK, and it feels like there are some efforts by these companies to shape regulation to be more friendly, which the EU AI Act is not super friendly to businesses. And on to the lightning round, we have generative AI services pulled from Apple App Store in China ahead of new regulations. Multiple generative AI apps have been removed from the App Store ahead of these regulations that are set to take effect on August 15th. The Chinese developers received notices from Apple informing of the app removal, citing content that is illegal in China. And these regulations are, quite new and coming in quick, and they are pretty strict. So, they require kind of opt-in and transparency and a lot of things with regards to being able to provide generative AI.
Yeah, and there's a requirement to obtain what's known as an administrative license, and apparently that's explicitly called out in Apple's removal notice. So it's very clear that this is the reason for it. Apparently, over 100 apps have been removed from the China App Store as a result of this. So one thing that they do call out that I thought was kind of interesting was the regulatory burden that this imposes, right? So, a smaller kind of upstart company that just wants to list on the App Store, it's like, now you got to meet this bar, and it's going to make it that much harder for new entrants to come in. Maybe a bit of regulatory capture potential there too. So kind of an interesting thing to keep an eye on.
Next, also from The Guardian, we have experience calling scammers used AI to fake my daughter's kidnapping. And this is a story about this real case where a mother received a phone call from someone claiming to have kidnapped her daughter and demanding a ransom of 1 million. The mother agreed to pay 50,000 and was instructed to meet the kidnapper, but another parent did inform her that it was an AI scam. But then she didn't believe the neighbor, but eventually she did speak with her husband and daughter. So, real, concrete example of what we've been covering more and more of this kind of scamming becoming more prominent.
Yeah, I really kind of horrifying read, I gotta say. Like, this is one for the trigger warning category for sure. Apparently the voice was totally realistic, and anyway, it will spare you some of the gruesome details. But one of the interesting details here was apparently this girl whose kidnapping was faked in this way, she has a very small presence on social media. So supposedly her social media accounts are private. There are some videos apparently of her being interviewed for sports in school, but nothing of her doing the things that she was doing on these fabricated sort of tapes of crying out and all that stuff. And so I think that's kind of interesting because, it's not just schmucks like us who have a 2-hour podcast every week talking about AI who are at risk of having our voices replicated. Like, this is, some average person, very limited, in fact, it seems, social media profile. And even that can be mined for this stuff. So pretty remarkable phase transition in the tech.
Definitely. And yeah, I mean, this is one of those things that you probably should take away from a podcast. This may happen to you. It's not clear
Yeah.
how prominent it is, but it's very, I would imagine, and from reading this, it's clear it's very shocking, right? Because it goes immediately to the emotional part of your brain. And it's hard to be critical and sort of, ask, well, does
Yeah.
this make sense when you hear this kind of thing that sounds like uh, someone you love? So it's bad, but it's happening.
Next up, we have the Stanford University boot camp teaching Congress about AI. So it's not going to be a surprise that Congress is interested in AI. It's not going to be a surprise with all the executive order stuff or the White House voluntary commitment stuff that we've covered and all that. People are really interested in getting upskilled here. What this story is about is a Stanford 3-day course that's designed specifically for congressional staffers to teach them about AI. And the issues they're covering are very wide-ranging: international security, future of work, bias, privacy, healthcare. Apparently there are field trips involved, interactive experiences, all that good stuff. And supposedly a ton of interest. So they took applications last year. They've seen a 40% increase in applications this year. And in one little interesting detail, they're actually doing this on site in Stanford because they don't want the distraction of Washington, D.C. life for the attendees. They want them to be able to kind of be immersed in all this. And in parallel, they mentioned Senator Chuck Schumer is also planning a crash course in AI for senators this fall. So that's not going to be for their staffers. That's actually going to be for senators. And they're bringing in top experts and as part of apparently at least 9 forums. And there they'll tackle workforce issues, national security, high-risk AI models, existential risks, which I thought was really interesting, privacy, transparency, and explainability, as well as elections and democracy. So no shortage of topics for people to learn from in the coming months, it seems.
Indeed. This 3-day bootcamp is run by the Stanford Institute for Human-Centered AI, which has done a lot of this kind of more policy-oriented, less necessarily technical work. It looks a lot at the implications of AI for its impacts. And, as someone who lives in the US, it's easy to be cynical and think that maybe our senators are not so tech savvy. So it is kind of nice to see that there are very kind of real efforts here to understand the technology, understand its limitations, and actually have informed lawmakers to be able to create this regulation that is currently being drafted.
I will say you guys have some really like impressive senators, and it's like at a bipartisan level. Gary Portman Rob Portman and Gary Peters have like done a bunch of really interesting stuff around tech. And it's been cool how bipartisan this is too. That's something that Stanford called out here too, right? They were saying like, hey, we're not going to just be the trained Democrat school or the trained Republican school. They're really trying to focus on everybody. So anyway, I think, I don't know, I've been really inspired from what I've seen of the U.S. Ecosystem, the kind of at the political level, people really taking this seriously, and hopefully it continues.
Wow, being impressed by the U.S. government. That's not something a lot of Americans feel these days, but maybe it's deserved. Last story in the section: 8 months pregnant and arrested after false facial recognition match, from the New York Times. So this is another story that's more of a narrative about this person, Portia Woodruff, a pregnant woman, a Black pregnant woman who was falsely arrested for robbery and carjacking based on a false recognition match. Woodruff is the 6th person and the first woman to report being falsely accused due to facial recognition. And we've seen a couple of cases of this last year where people, get arrested, and then it turns out that with some simple investigation, it turns out pretty easy to see that it's the wrong thing. So it's another example of you got to use this technology carefully.
Yeah, over reliance, and well, good on her. Looks like she's filed a lawsuit. So assuming the case is what it sounds like, hopefully that's a good source of, let's say, financial pressure on the police department there to change their practices. And hopefully that improves for next time. Jeez.
This is apparently the third case involving the Detroit Police Department, and the department runs on average 125 facial recognition searches a year. So yeah, I mean, this is one of those things where have already been cases where people got hurt by misuse of technology, and it's one of those things where you really got to vet it and use it properly.
Yeah, it's also interesting, if this is not the first time for the Detroit Police Department, at least to report being falsely accused. So 6% out of presumably 125 searches. So that's like, that's like a decent. Am I reading that right? Like that seems like a decent.
It's actually the third case.
The third case. Okay.
Yeah, in this case, yeah. But,
okay.
Yeah, it's surprising still.
Yeah.
And on to our last section, synthetic media and art. We just have a couple of stories. First is Greg Rutkowski was removed from Stable Diffusion, but AI artist brought him back. There's the digital artist named Greg Rutkowski, who is known for his vivid, surreal style. And his name was often used in text prompts to, create art that looks like his. Stability AI that made Stable Diffusion removed his art from the training dataset after he opposed it. And then this article covers how the community has then created a new model that brings it back and lets people do it. So it's kind of showing how it's hard as an artist to really prevent people from doing it if your work is out there.
You don't choose the AI chooses you, man.
Yeah, so complicated topic, right? And we see more and more of these kind of tricky cases, and this is one more. And last story, an Asian MIT student asked AI to turn an image of her into a professional headshot. It made her white with lighter skin and blue eyes. That's the story there. So there's been more of these tools that, give an image and it generates a headshot for, your LinkedIn or even for dating apps. And this is one of these classic AI bias things where, if you don't use an AI that is really robust to work for large populations of people, you'll get these kinds of bad outcomes that kind of clearly indicate your tool is biased in this way.
Yeah, I mean, it's ultimately so difficult to debias these systems, and the impacts can be so so emotionally jarring. But yeah, I mean, it's the kind of thing. Like I don't know if this is a data set problem. I don't know if it's a training objective problem or whatever else. But yikes.
Let's hope this wasn't a tool that's specialized in this particular application. I think this is a kind of more general text to image prompt. So there's an instruction of give the girl from the original photo a professional LinkedIn profile photo, which then kind of a professional LinkedIn photo apparently implies someone white, according to this. But yeah, it's also a case of if you are offering this specifically as a service, you definitely need to check against this being an outcome. In this case, maybe because it's a general service, it's still bad, but
yeah, like kind of a surprising use case maybe for them or something like that.
Yeah. And that is it for us, a bit of a shorter episode. Thank you so much for listening. As always, you can email us at contact@lastweekin.ai with any comments or feedback. Please subscribe, please share, please give us some 5-star reviews or 3-star reviews. But as always, we really only care about you listening. Be sure to keep doing it.